right? How do I know it's a right triangle? They tell us this guy's 58 degrees. How do we know this is a right triangle, and how do we solve for x? Well, this has to be a right triangle because any tangent line and radius, they do what? They are perpendicular, meaning they create a right angle, meaning this guy is a right triangle. And what I know about right triangles is this: that right angle plus the angle they gave us plus whatever x is has to equal 180 degrees, because all three angles in a triangle add up to equal 180 degrees. All right, so from there you get 148 plus x equals 180. Subtract 148 on both sides, and x here equals 32 degrees. Okay? So that's how that comes about. And then we made it a little bit spicy. We turned up a little bit, okay? Turned up a little bit on the second one. So on the second one, we have our circle C, okay? We have an external point, all right, and they're asking us, oh, and C, it's supposed to be a C, sorry. Then we have these two radii drawn, and they tell us that this degree measure right here is 130 degrees. All right, and they're asking us to find that guy right there. Ooh, sorry about that, y'all. All right, now, so how do we go about this problem? We have to remember the rule says that the radii and the points of tangency, the radius and this point of tangency here, the radius and this point of tangency here create that is a perpendicular line. These lines are perpendicular. All right, meaning they're both right angles right there. So watch this. What does that mean? Well, if I'm trying to figure this thing out, I need to cut this up into two right triangles, meaning I'm cutting this 130 degrees in half. So that's no longer, I mean, that's still 130 degrees, but now in the two separate triangles, it's 65 over here and 65 over here. Which means that if I have this angle and this angle, can I find this one down here? Absolutely, right? Because I know that whatever I get for x, I'm going to multiply it times 2, and that's going to tell me my whole angle. All right, so I end up with 90 plus 65 plus whatever that x is, it equals 180. All right, I don't have to do it twice. I know I got two different triangles. I don't have to do it twice because these triangles have the same measurements in them. All right, so that's 155 plus x equals 180. Subtract 155 on both sides, and x equals 25 degrees. All right, so now if it's 25 over here, that means it's 25 over here. So 25 plus 25 equals 50 degrees. So x equals 50 degrees. I shouldn't have put a box around that. Let's just say x equals 25, and then the final answer is 50 degrees. Okay, so again, tangent lines are not hard. We just have to remember their rules. Okay, we must remember their rules. All right, and if you forget rules, feel free to go back in the video and look at the rules again. All right, and then we have this chart here. All right, I want to go through how the chart works on the first one, and then you guys can do 4, 5, and 6 in the independent practice yourself. Okay, so here we have this chart, and I'm going to put chart at the top so y'all know what we're talking about. Okay. All right, they give us this circle here. They say a circle with a center of O. J is our point of tangency. K is our external point. And L is where this line crosses. So we have radius OL, we have radius OJ, all right, and it creates a right triangle. Okay? All right. So the first one says, for number one, it says OJ equals 4. KL equals 5. They want us to find JK. Right now, I know for a fact that this is a what kind of triangle? A right triangle. I know it's a right triangle because radius and tangent line are perpendicular. Okay? So now, if OJ is 4, then that means OL is what? 4. So all I'm going to do here is I'm literally just going to redraw the triangle so we can see it. All right, this is J, this is O, this is point L, this is K. I didn't draw it in the circle. I just drew it as a triangle so we could separate it a little bit. All right, now watch this. So if OJ is 4, let me put that in a different color, I'm sorry. OJ here is 4, and OL, if this is 4, then OL must be 4 because they are both radii. OJ is equal to whatever OL is because they are both radii, okay? All right, they're both radius of the circle. All right, and then they told us that KL here was 5. So this whole side here, this is 4 and this is 5, the whole side is 9. Anytime I have a right triangle, if I have two sides of it, I find the third side using Pythagorean theorem. Find JK using Pythagorean theorem, right? We know Pythagorean theorem is a squared plus b squared equals c squared. The hypotenuse is OK, right? So that's C, and then A and B can be either one. All right, we know that this is the hypotenuse because it's across from the right angle. All right, so now we just substitute and solve. So we have 4 squared plus the side we don't know, so we're going to call that x squared equals 9 squared. That's 16 plus x squared equals 81. Subtract 16 on both sides. X squared equals that is 65, and we take the square root. So x equals square root of 65, and you can leave it just like that. If I wanted you to put it in decimal form, you just turn it to a decimal. All right, and this is how the rest of the examples is done too. We're gonna do, I'll do this one with you as well. Actually, no, I won't. I'm going to move to